See Lindelof solving radical equations with some emphasis on extraneous solutions, and also why is this principal root thing necessary? Something to look up. What's the principal root or the principal square root of something? Why is that important? I guess the first thing I would do if I was looking at this equation is keep in mind that what I want to do is I want to get this radical by itself. That's my initial goal, is to get this thing by itself. So to do that, I'm going to add positive n to both sides, and then we'll get the square root of 6n plus 19 is equal to 2 plus n, or n plus 2. It really does not matter. Now that we have the radical isolated, then what we want to do is we want to start working on getting rid of this radical. And to get rid of the square radical, you square it. And remember, if you square one side, you have to square the other. When you square a square root, that root is canceled, and you are left with 6n plus 19. So the radical's gone. That's good news. Here's where people get into trouble sometimes, is they think that they can distribute this 2 here and here. But if you check, you'll see that that is actually not true, because n plus 2 squared means n plus 2 times n plus 2. And here, if you do your FOIL, you'll get a little bit different answer, won't you? You'll get n squared plus 4n plus 4. So if you expand this out, that's what you would get. This is what I'm noticing now. It's really, really important in algebra, is to look at what kind of equation you have. Because I have one of my variables squared, and it's the highest exponential value is 2, I realize that this thing is kind of a quadratic. So what I want to do is I want to move everything to one side. So what I'm going to do is I'm going to subtract 6n from both sides and negative 19. So I'm going to put my negative 6n here, my negative 19 here. I'm going to start simplifying a little bit. This side we get 0, right? And we get n squared minus 2n minus 15. Okay, so it's actually looking pretty good. From here, we're going to factor. I'm going to just factor this thing out a little bit. And if you factor this out, we'll get n, what is it? N minus 5, yeah, n minus 5 times n plus 3. Remember, equal to 0. So here's that 0 right here. And then remember that we're going to solve each of these factors for 0. So I said n minus 5 is equal to 0, and that's true when n is equal to 5. I said n plus 3 is equal to 0. That's true when n is equal to negative 3. Here's the good news and the bad news. The good news is that both of these answers are accurate, but given the situation, they're not necessarily both true. So what you have to do is go back to the original equation, right? We got n equals 5, n equals negative 3. So n equals 5, n equals negative 3. So we go back through this and solve, and as we do, we find that we're going to get a negative number here. Look, just when I have n is negative 3, if I put n is negative 3, a negative is a positive. When so I have to subtract 3 from both sides. I get is equal to negative 3. I don't even give a crap what this thing is, what the square root of this is, because it's not negative 3, because when we do radicals, we use principal roots. That is, when we take the square root, right, your teacher will say to you, what's the square root of 9? And hopefully you'll say plus or minus 3. Well, when you're taking principal roots, you only take the positive, and therefore the principal root of this thing right here cannot be a negative number. So we have negative 3 is an extraneous solution, so only 5. And this one, your teacher or professor may want you to identify this as extraneous. All right? And again, extraneous doesn't mean wrong. It doesn't mean it's bad math. It means that it's not relevant to the problem that you're doing. All right? I hope this was really helpful. If you have any questions or comments, please let me know. And if you haven't already subscribed, please do. Thanks.